Let us solve another question. For a simple two-plant power system, the loss coefficients are B11 is equal to 0.001 per megawatt. That means megawatt inverse. So we know that if powers are in megawatt, B coefficients are expressed in megawatt inverse. So B12 is equal to minus 0.0005 per megawatt and B22 is equal to 0.0024 per megawatt. The incremental production cost of the units are dC1 by dP1 is equal to 0.08 P1 plus 16 and dC2 by dP2 is equal to 0.08 P2 plus 12 rupees per megawatt hour. So see, sometimes the incremental cost are given as dC1 by dP1 and dC2 by dP2 like that. And in certain cases, it will be given as IC1 and IC2 incremental cost. So in all the cases, understand which one is the incremental cost. So find the generations P1 and P2 for lambda is equal to 20. Also compute the transmission loss, received power and efficiency of the transmission system. So up to this part, the question is similar to the previous question, and here we have to calculate a few more things: the transmission loss, received power and efficiency. So now let us solve the problem. So we know the condition for solving economic load dispatch between different plants in a power system network. The equation is Li into dCi by dPi is equal to lambda, where Li is the penalty factor. So here in this question, we are considering two power plants. So the equations are L1 into dC1 by dP1 is equal to lambda and L2 into dC2 by dP2 is equal to lambda. Now what is L1? L1 is equal to 1 divided by 1 minus dou PL divided by dou P1, and L2 is equal to 1 divided by 1 minus dou PL divided by dou P2. So now we have to calculate L1 and L2. So for that we need PL, that is the transmission loss. So as it is a two plant system, the transmission loss equation can be written as P1 square B11 plus P2 square B22 plus 2 P1 P2 into B12. The B coefficients are already given in the question. Value of B11, B22 and B12 are given in the question. So substitute the values and write the transmission loss. So PL equal to 0.001 P1 square plus 0.0024 P2 square minus 0.001 P1 P2. So after substituting the values of B11, B22 and B12, the transmission loss equation will be like this. So now we have to calculate dou PL by dou P1 and dou PL by dou P2. So let us calculate dou PL by dou P1. So differentiating this equation with respect to P1. So this term becomes 2 into 0.001 into P1, that is 0.002 P1. Now there is no P1 in this term, so derivative will be 0, and this term derivative of P1 becomes 1 and remaining term is 0.001 P2. So this is dou PL by dou P1, and now calculate dou PL by dou P2, which is equal to, so derivative of this term will be 0 and derivative of this term will be 2 into 0.0024, that is 0.0048 P2 minus 0.001 P1. So now use this equation and substitute the values. So L1 into dC1 by dP1 is equal to lambda. Implies, what is L1? 1 divided by 1 minus dou PL by dou P1. That is 1 divided by 1 minus dou PL by dou 1 is this. That is 1 minus 0.002 P1 minus 0.001 P2. So that is L1 into dC1 by dP1. So what is dC1 by dP1? So dC1 by dP1 is 0.08 P1 plus 16. So into 0.08 P1 plus 16, which is equal to lambda. So lambda is given as 20, equal to 20. So now simplify this equation. Equation can be written as 0.08 P1 plus 16 equal to 20 into this term. 0.08 P1 plus 16 is equal to 20 into 1 minus 0.002 P1 minus 0.001 P2. So simplify this equation and obtain an equation in terms of P1 and P2. So it will be 0.12 P1 minus 0.02 P2 is equal to 4. Mark it as equation number 1. So now go for the second equation. L2 into dC2 by dP2 is equal to lambda. L2 into dC2 by dP2 is equal to lambda. Implies, now what is L2? 1 divided by 1 minus dou PL by dou P2. 1 divided by 1 minus dou PL by dou P2. So dou PL by dou P2 is this term. 0.0048 P2 minus 0.001 P1. So L2 into dC2 by dP2. dC2 by dP2 is 0.08 P2 plus 12. So 0.08 P2 plus 12 is equal to lambda, that is 20. So simplify this equation also. You will get it as 0.176 P2 minus 0.02 P1 equals 8. Mark it as equation number 2. Now solve equations 1 and 2. So on solving equations 1 and 2, you will get the value of P1 as 41.7 megawatt and P2 as 50.2 megawatt. So this is the economic load scheduling between the two plants. So now we have to calculate a few more terms here. So they are the transmission loss, received power and efficiency of the transmission system. So we have to calculate the transmission loss. So we know the equation for transmission loss. 0.001 P1 square plus 0.0024 P2 square minus 0.001 P1 P2. So now we got the values of P1 and P2. On substituting P1 and P2 in this equation, we can calculate the transmission loss. So transmission loss will be equal to loss PL equal to 0.001 P1 square, that is 41.7 square, plus 0.0024 P2 square, that is 50.2 square, plus 2 into P1 into P2 into B12, that is minus 0.0005. and the answer will be 5.694 megawatt. So this is the transmission loss occurring in the system. So now another term that we have to calculate is the received power. So what will be the value of received power? Received power PR will be equal to, it will definitely be equal to total power generated, that is P1 plus P2 minus the loss occurring in the transmission line. So received power received by the load will be equal to total power generated minus the loss, that is 41.7 plus 50.2 minus 5.694, which is equal to 86.204 megawatt. So now we have to calculate efficiency of the transmission system. Efficiency of the transmission system, and it will be total power received by the load divided by total power generated. Total power received divided by total power generated into 100%, that is 86.204 divided by 41.7 plus 50.2 into 100%, which will be equal to 93.6%.